Hey guys, so I'm just giving you an update on my Benchtop Pro 2436. I've been really busy. I haven't had a whole lot of time to get this thing put together, so it's taking me a little longer than I thought. But this is it. Still some things I'm going to need to do, but I'm just about ready to start making chips now. Everything's wired up. So I've got a little console that I made here that's just 3D printed, and it's got cycle start, cycle stop or feed hold, Z positive and negative, and then this is my rapid toggle there, and then I can jog the machine. This is X negative and positive, and then this is Y negative and positive, and then I've got E stop. And then I got a Drewtronics touch probe here that's all wired up, and then I haven't got my tool setter yet. I've got my cable ready to go for that. For when I get that, it's probably gonna end up going like right here. Then I've got everything wired up down here, and so I've got a Masso G3 for the controller, and you can see I've got the NEMA 34 closed loop steppers. I highly recommend closed loop because open loop steppers, if you lose a step, there's no way for the controller or the driver or anything to tell if it has. So there's built-in encoders in these steppers that monitor the steps that have been received or output by the driver, and the encoder reports back and tells the driver that it actually moved that far, and if it didn't, it will recover that step that was lost. If it can't, to a certain point, it will trigger an alarm and halt the process, meaning if it jammed against something or the torque went up too high or something like that, it will halt the process or the job that's running at that moment, and allow you to correct the error and resume the job without losing it. So then I've got my 4 60-volt switching power supplies for the controllers. Each one is isolated to each stepper driver, and then I've got 12 volt and 24 volt, and then they're going up into their own bus bars there, where this power is distributed to the Masso controller itself, other various hardware, as well as the relay control module, and the 12 volt bus bar is powering just my liquid cooling system for my spindle right now, and that is all under here. So it controls the fans at the radiator, and also the pump for the pumping the coolant around. And then AC side, I've got 3 circuits coming in, 2 for the VFD, and then I've got 1 to power everything else here. So each section has its own 120 volt circuit or 220 volt circuits, and then they're all ran up to this changeover switch, and then back. So everything is turned on or off by this changeover switch. So the other thing I've got going here is these limit switches. So I went with optical limit switches by Masso, same company that makes the controller. They're accurate to within 10 microns or less. I wanted high accuracy, so that's why I went ahead with those, and I've kind of installed them in line with the hole for the original proximity sensors. And then I've got these M3 threads that threaded rod that act as a flag. So it actually pokes through that hole there and triggers the switch. So I've got that on all axes. I got one on the Z, and then I've got two on the Y. You can kind of see the other one over there. So I made these little brackets here, and I designed them so that if and when you get a chip that goes up in the hole here or something like that, it will find its way out the bottom and not collect in there and mess up the homing sequence. So it does have auto squaring built in, and that is adjusted by screwing in the threaded rod further or one side or the other. By depthing those in or out, you can control the squareness of when the switch is triggered. So each axis is treated as its own. So it's treated like a 4-axis machine right now. Anyway, so I'll turn this thing on. Everything boots up. Got Masso loading up here, and I've got it set up to prompt for emergency e-stop, just to make sure that it is operating correctly, and then it's prompting for home as well. So back to the console, you can see I've got all these buttons here are lit now, and so I'll hit my e-stop, and you'll see that error code will clear. And then this, and I'll turn up my feed rate, and now it's ready to be homed. So I will home it now. So I've got the resolution of the steppers set to 5,000 pulses per revolution, and 10,000 millimeters a minute. So it's pretty quick. My Z. I have my soft limit set up so that my Z will never collide with the Y axis. It'll go way down. Probably gonna have to adjust this a little bit, but it looks really bad there, but it will not go any further than this. So I just wanted to have full access to my bed. It will actually travel farther, but I've got it limited so that it will not crash into the side of my Y-axis rails. Anyway, so yeah, it's pretty nice so far. One thing that I wanted to say before the video ends here is when I was putting this thing together, the way they tell you to do it, you're going to want to install 2 of your T-slot cross members here and bolt them down to your other cross members, and then loosen up all of these studs that attach to the axes here, so that they can self-align to the T-slots, and then retighten them. So my machine was kind of skewed a little bit. This corner was kind of lifting a little bit like that, and I went ahead and did that, loosened things up and let it relax, and then tightened everything back up. I highly recommend doing that. So anyways, just wanted to share that update here. Oh, and this whole thing folds away when I'm done here. So, alright, take care, guys.